everybody. Today we're going to learn possibly one of the most important things that you are going to learn in algebra, which is finding the zeros of a quadratic. Before we start, I'm just going to talk quickly about our experience with solving equations. We've learned how to solve just about every type of equation except those that are dealing with x squared and also another term that has a different exponent. So in other words, we don't know how to solve a quadratic equation. Today is the day that you will learn how to do this. It's actually very easy, and it ends up being kind of fun for those of you who enjoy algebra, and it's super important, so make sure you watch the whole video. So in order to lead up to this, we're going to take a look at the zeros of a function on a graph. So the x locations on any function where the output is equal to 0 are known, not surprisingly, as the zeros of a function. We've talked about them in different lessons where we said the zeros are just where the graph crosses the x-axis because that's where y is equal to 0, right? So just somewhere off to the side if you need to. The zeros are where y equals 0. And in other words, that's where the graph crosses the x-axis. Okay? That's just a little side note for you. So if we look at this graph, I'm sorry, I skipped up here. So these are amazingly important in applied settings. So like I already said, they're super important. When they are rational numbers, we can find them using a factoring technique. And we're going to develop the idea in this exercise. So we're going to lead up to it. This quadratic equation here is x squared minus 2x minus 3. This is the graph of that. What are the zeros? So to find the zeros, you just look and see where they cross the x-axis. That's where y is equal to 0. So I have one 0 here and another here. So that's -1 and 3. So the zeros are -1 and x equals 3. Okay? Those are the two zeros. So first we're going to do we're going to verify that the positive 0 is correct by showing that y is equal to 0 when we plug it in. So which one of these is the positive one? That would be x equals 3, right? So we're going to take our equation and we're going to plug in 3 for x and show that we do get y equals 0. So 3 squared, minus 2 times 3, oh dear. I'm going to switch to a pen. Minus 2 times 3, minus 3, okay? And remember, you don't need to make yourself stressed out. Just plug everything right in your calculator. 3 squared minus 2 times 3 minus 3 equals 0. So we have verified that y does indeed equal 0. Next, we're going to factor. So we're going to factor this expression, and what we're going to do is we're going to show how the factors relate to the zeros that we found. So, double bubble. We have a leading term of x squared, so that means we don't have to worry about the a value. It's just going to be x and x. Our last term is negative, which means one of these is going to be negative and one of them is going to be positive. So I'm going to just do a plus and a minus. And if the middle term is negative, that means that the larger number is going to be the negative one. So you think of the factors of -3 that will multiply together to give us -3, but we'll add to -2. So if you want to take it off the side like we used to do, this would be, -3 times 1 will multiply together to give me -3, and they will add together to give me that -2. So it's going to be 3 and 1. So now what we want to do is we want to look at how these factors compare to the zeros that we found. If you look closely, what you'll notice, the 0 was x equals -1. The factors says x plus 1. The other 0 is x equals 3. My factor says x minus 3. So they appear to be opposites, right? So let's look at it a little bit further. For part D, based on what we just saw in C, we're going to determine where the zeros are. algebraically of this function, then we can verify it using a table and our calculators, of course. So we're looking at this. We're going to factor it first. And it seems to be that if our factors are, if we factor out and we get these two binomials, it seems to be that the zeros are based on what we have here. So let's try it out. If we factor this, we have a double bubble, of course. And we have x and x. Negative means we have two different, plus and a minus. The middle term is positive, so the larger number is going to be the positive one. You just want to think what two numbers are going to multiply together to give me negative 10 and add up to positive 3. That's going to be 5 and negative 2. So the 5 is the positive one, 2 is a negative 1. So this is now factored. To find zeros, what we're really doing is setting this equal to 0. Now, how did we get this negative 1 and 3? It wasn't just that they're opposites. What you actually do, and I'll show you, is you're basically splitting these up and you're setting each of them equal to 0 and solving. So x plus 5 is equal to 0, and I solve it. So x is equal to negative 5. And on this side, x minus 2 is equal to 0. Solve for x. X is equal to 2. And that is why it appeared that the zeros were opposite of what we had in the factor. What we really did was we solved both of these when they were equal to 0. And guess what, guys? This is actually how you solve a quadratic equation, if you can factor it. Okay? So what is really going on here is perhaps the second most important equation solving technique, known as the zero product law. So this is a zero product law, and what it says is that if you know that a times b is equal to 0, then either a or b have to be 0, or both of them could be 0. So using this idea, if we know that this is equal to 0, when we break it up, either one of these could be equal to 0. So when we solve it, we have to account for both cases. So what you do is you break it up, you solve each one, setting it equal to 0, and that gives you your zeros for your equation. Thinking about the fact that we're dealing with a quadratic, so it is most likely going to be crossing your x-axis twice. Now, are there cases where x is not equal 0? Sure. So we'll talk about that later. So for exercise 2, we're going to use the zero product law to find the solutions to these equations. These ones have already been factored. So all we're doing is just looking at how we use the zero product law here. So we're imagining that we've already factored this, and now we have it equal to 0. So what you do from here is you break it up, and you set each piece equal to 0 and solve. So this is x plus 7, so this becomes x plus 7 equals 0. And this one's going to be x minus 2 equals 0. And you solve them separately. So subtract 7 from both sides, and x is equal to negative 7. And over here we add 2 to both sides, so x is equal to 2. So to write the solution, or zeros, we can write it separately. We can write x equals negative 7 and x equals 2. Or you can write x equals negative 7, comma 2. Or you can do it like this, the solution set. This is a very common way, 7, 2, like this, okay? And that's how you use the zero product law. I'm gonna stick with this method for now because it's something that you'll use in higher level math, okay? But you can write it either way like this too. For part B, this has already been factored again, so you're going to split it up and set both equal to 0. And this is showing that, of course, you don't always have just a nice easy binomial like that. Okay, and so it's going to be 2x minus 1 equals 0 on this side, and on this side it's 3x plus 4 equals 0. And now we solve. Add 1 to both sides. You have 2x equals 1. Now divide by 2 on both sides, and x is equal to a half. Now on this side, subtract 4 from both sides. 3x is equal to negative 4. divide by 3 on both sides, and x is equal to negative 4/3. So your two zeros are 1/2 and negative 4/3. So your solution is 1/2 and negative 4/3. And generally we would write the smaller one first, so I'm just going to do negative 4/3 and 1/2. That's how you find zeros. And to be clear, your zeros are the solutions to this equation. Okay? So what we're going to do now is we're going to just extend the practice by factoring first. So there's another way of calling, there's another name to call the zeros, and it's very commonly used, so I do want you guys to know it, and that would be the roots. So if you are ever asked to find the roots of a quadratic equation, that means you're finding the solutions, and it also means you're finding the zeros. Okay, so these three words are interchangeable when it comes to solving a quadratic equation. So we've never been able to do this before. We've never been able to look at this and actually solve. Remember that you are not solving this equation by drawing a line and doing inverse operations. You have to factor first, and then you use the zero product law. Okay? So first things first, we're going to factor. You can use whatever factoring method you like. For this first one, it's going to be nice and easy to just double bubble. Okay? Don't forget the equal 0 at the end, though. That's kind of the most important part. So we're thinking of two numbers that will multiply together to give us negative 12, but we'll add to positive 4. Since it's negative, there's a positive and a negative. And since the middle term is positive, that means the larger is positive. So this is going to be 6 and 2. 6 times negative 2 will give me negative 12, and 6 plus negative 2 will give me 4. So it's factored, and now I'm going to be able to solve. Breaking it up, I'm going to set x plus 6 equal to 0 and x minus 2 equal to 0. And then I solve. This one's nice and easy. Subtract 6 from both sides. X equals negative 6. That's 1, 0, or one solution. And then over here I add 2 to both sides. X equals 2. These are my two solutions, my final solution set. Write the smaller one first. Negative 6, comma 2. That's my solution. Okay? So let's show another one where we have to factor. It doesn't always have to be double bubbling. It doesn't always have to be grouping. Sometimes it could be GCF. So if you look here, you can see that there is a GCF of 2 and x. So if you pull out a 2x here, you'll be left with x minus 7 equals 0. This is still something you can use the zero product law to solve. You just break up each piece and set it equal. So 2x equals 0 and x minus 7 equals 0. Okay, divide by 2, and here x is equal to 0, and over here you add 7, so x is equal to 7. So your solution set is 0, comma 7. Okay? Remember, when you're factoring, you always want to be checking for a GCF first before you do anything else. In this case, I knew there was none because we only have x squared here. In this case, I'm looking at this and I can see that this is clearly difference of two perfect squares. And for D, I'm looking at there's no higher exponent than x squared, and none of these coefficients have something I can factor out. So this one's going to probably be grouping. So what I want you guys to do is pause, try these two yourself, solve them, and then unpause to check your answers. Make sure you stick around to see the last question. Don't just leave after this, okay? So pause, try it, and come right back. Okay, so for C, this one's nice and easy. This is a difference of two perfect squares. So you're going to have x plus 5, x minus 5, and split it up. You get x equals negative 5 and x equals 5. This one was a little trickier. If you do it by grouping, remember you should be multiplying a and c. You get negative 24. You want to figure out the factors that will multiply to negative 24 but add to the middle term, which is 5. Okay, so you'll find 8 and negative 3. They add up to 5 and multiply to negative 24. So when you factor out your GCF, you should get 2x times x plus 4 on one side, and then you factor out a negative 3 on this side. So your x plus 4 comes out. I wrote it on this side though. Times 2x minus 3. Split it up, solve for each, and you got negative 4 and 3 halves. Okay? We're going to do the last one together. Find the zeros of the quadratic function algebraically, and then verify using the calculator. We'll sketch the graph using the window that they've given us, and then we'll mark the zeros on the graph. So first we're going to do it algebraically. So we have y equals 3x squared minus 6x minus 24. So like I said before, you always want to try to see if you can factor out a GCF first. So I'm going to first set this equal to 0, because that's our goal here, right? And this time you'll see that there is a GCF of 3. So we should try to factor out the 3 first. This leaves us with x squared minus 2x minus 8 equals 0. And then we can factor the term on the inside now, nice and easy. Keep the 3 on the outside, and then we'll see. We can double bubble this, x. This is negative, so it's a plus and a minus. The middle term is negative, which means that the bigger number is going to be negative. So it's going to be 4 and 2. So 4 is going to be negative and 2 is going to be positive, equal to 0. And now we split this up, and we set it equal to 0. The 3 is completely irrelevant here, because it can't be equal to 0, so we don't have to worry about it. We're going to actually just ignore it, because basically you would have to say 3 equals 0, which will never be true. So x plus 2 equals 0, and x minus 4 equals 0. Subtract 2 from both sides. X is negative 2. Add 4 to both sides here, and x is equal to 4. So our solution set would be negative 2 and 4. So we found it algebraically. And now we are going to take a look at the graph. So we want to use this window that they've given us. So when you begin, you go into y equals, clear out whatever you got. Let's put in our new one, 3x squared. 3x squared minus 6x minus, 24. And before I graph it, I'm going to go into my window and change. X min should be negative 5. X max should be positive 5. Leave your scales alone. The y min now is negative 30. And my y max is positive 30. Let's take a peek. Okay, so we can see our graph looks like this. See if my pencil will at least do that. Something like that. Okay, and if we want to verify our zeros, we go to the table and we look at where y is equal to 0. So 4, we said 4, and then we should also find negative 2. So go to negative 2 and see, it's a 0. So as you can see, this is approximately negative 2 here, and this is 4. It really should be a little further over here, but it's a sketch, right? And that's that. Okay, guys, so you have another lesson tomorrow. It's all practice with this. So you're going to be doing this without a video for tomorrow. It's just additional practice with this stuff, solving a quadratic equation by finding the zeros. So just to clarify one more time, every time you're solving, you want to first try to factor out a GCF. If you can't, you just keep going with the factoring. If you can, you continue to factor until everything is factored completely. Then you solve each side of the each piece for a 0. If you have a number outside like this, a constant, a coefficient, it doesn't matter. Okay? So that's that. Have fun.